The universe is full of extremes. We see it in the crushing gravity of a black hole, the brilliant fury of a supernova. But sometimes the most shocking extremes happen right here, on our own small blue world. Consider the city of Buffalo, New York, during the Christmas season of 2022. It wasn't your typical holiday scene of gentle snowfall and cozy fires. Instead, an unrelenting blizzard, a meteorological beast of historic proportions, descended upon the region. The storm wasn't just snow, it was a furious combination of hurricane-force winds, plummeting temperatures, and a suffocating deluge of white. It was a weather event that turned a modern American city into a frozen, isolated wasteland in a matter of hours. Imagine the scene. The sky, a churning cauldron of gray and white, unleashed snow at a rate of inches per hour. Winds howled with the force of a Category 1 hurricane, sculpting snow into monstrous drifts that buried cars, homes, and roads entirely. Visibility dropped to zero, a true whiteout condition where you couldn't see your own hand in front of your face. Emergency services were paralyzed. Plows were rendered useless, getting stuck themselves. For days, thousands were trapped without power, without heat, as the temperature plunged far below freezing. This wasn't merely an inconvenience, it was a life-and-death struggle against the raw, untamed power of nature, a stark reminder of our vulnerability. This event, dubbed the Blizzard of the Century, was more than just a bad storm. It was a signal. It was a message from our planet's climate system, written in ice and wind. How could such a ferocious winter assault happen in a world we're told is getting warmer? It seems like a paradox, a cosmic riddle. To understand our winters, we must first look to the stars, or more precisely, our star. The Earth is a traveler on a cosmic journey, an annual pilgrimage around the sun. Our planet doesn't sit straight up and down as it spins, a jaunty angle of about 23.5 degrees. This tilt is the secret ingredient, the master architect of our seasons. It's a simple, elegant piece of celestial mechanics. When your part of the world is tilted toward the sun, its rays strike more directly. The days are longer, the sunlight is more concentrated, and you get the warmth of summer. It's a direct deposit of solar energy into your hemisphere's bank account. Now let's fast forward 6 months in our orbital path. Your hemisphere is now tilted away from the sun. The same sunlight now strikes your part of the Earth at a shallow angle. The rays are spread out over a much larger area, delivering less energy per square foot. The days become shorter, the nights longer. This is winter. It's not because we are farther from the sun. In fact, the Earth is slightly closer to the sun in January than in July. It's all about the angle of incidence. This cosmic tilt is the simple, beautiful reason we have seasons at all. It's a rhythmic, predictable dance that life on Earth has evolved to follow for eons. This predictable cycle has shaped everything from the migration of birds to the hibernation of bears, from the planting of crops to the very rhythm of human civilization. But what happens when a new force is introduced into this delicate, age-old dance? Think of the Arctic as the planet's air conditioner. For millennia, this vast, white expanse of sea ice at the top of the world has served a critical function. Its bright, white surface acts like a giant mirror. It reflects a huge amount of incoming solar energy right back into space. This phenomenon is known as the albedo effect. It's why wearing a white shirt on a sunny day keeps you cooler than a black one. The Arctic's high albedo has been a key component in keeping our planet's climate stable and our polar regions locked in a deep freeze. It helps maintain the sharp temperature difference between the cold poles and the warmer equator. But our planet has a fever. The blanket of greenhouse gases we've wrapped around the Earth is trapping heat, and that heat is having a dramatic effect on our polar air conditioner. The Arctic is warming more than twice as fast as the rest of the planet. This phenomenon, known as Arctic amplification, is causing that reflective sea ice to melt at an astonishing rate. As the white ice disappears, it exposes the dark ocean water beneath. And just as a black shirt absorbs more sunlight, this dark water absorbs vastly more solar energy. This creates a dangerous feedback loop. Warmer water melts more ice, which exposes more dark water, which absorbs more heat, which melts even more ice. This rapid warming of the Arctic is not just a local problem for polar bears, it's a global problem for all of us. The temperature difference between the frigid Arctic and the warmer mid-latitudes is a primary engine for the weather in the northern hemisphere. Specifically, it drives a massive high-altitude river of wind called the jet stream. You've probably heard the term polar vortex on the news, often spoken with a sense of dread. It sounds like something from a science fiction movie. but it's a real and persistent feature of our atmosphere. The polar vortex is a vast, rotating expanse of extremely cold, dense air that sits over the North Pole during the winter. For most of history, this frigid air mass was held firmly in place by the strong, stable jet stream we just discussed. The jet stream acted like a cage, a powerful atmospheric fence keeping the coldest air in the Arctic, where it belongs. When the jet stream is strong and stable, powered by that steep temperature difference between the pole and the equator, the polar vortex remains a tight, cohesive circle. It spins like a well-balanced figure skater, keeping its cold air to itself. North America, Europe, Asia. The cold is there, but it stays largely confined to the high latitudes. This was the pattern for generations, the rhythm of winter we came to expect. The system was in a state of relative equilibrium, a balance between polar cold and equatorial warmth. But as we've learned, the rapid warming of the Arctic is weakening the jet stream. The fence is breaking down. As the jet stream slows, its path becomes wavy and distorted. It develops deep troughs. It develops high ridges. Imagine that spinning figure skater now slowing down and flinging her arms out, becoming unstable and wobbly. These deep troughs in the wobbly jet stream are like open gates in the fence. They allow massive lobes of the polar vortex, chunks of unimaginably cold Arctic air, to break free and plunge southward deep into the mid-latitudes. So, a wobbly jet stream allows frigid Arctic air to spill southward. But where does all the snow come from? Here we encounter another seeming paradox of climate change. You might think a warmer world means less snow, and in the long run, on average, that might be true. But a warmer atmosphere can also lead to much heavier snowfall events. The reason is simple physics. Warmer air can hold more moisture. For every degree Celsius the atmosphere warms, it can hold about 7% more water vapor. This is the fuel for precipitation. When a frigid mass of polar air plunges south, it doesn't travel into a vacuum. It collides with the warmer, more humid air that is now more common in the mid-latitudes, thanks to overall global warming. You now have the two essential ingredients for a monster snowstorm: a massive reservoir of cold air to turn moisture into snow, an atmosphere supercharged with extra water vapor to provide the raw material. It's the perfect recipe for what meteorologists call a bomb cyclone, or more popularly, a Snowmageddon. These aren't your grandfather's snowstorms. They are steroidal, supersized versions. This isn't just an American story. The destabilization of our winter climate is a global phenomenon, sending shockwaves of extreme weather across the planet. In January 2021, while Texas was shivering, Madrid, Spain, was paralyzed by Storm Filomena. The city experienced its heaviest snowfall in 50 years, burying the capital under nearly 2 feet of snow. The army had to be called in to clear roads and rescue stranded motorists. It was so far outside the norm for central Spain it brought the region to a standstill. Let's travel across the globe to Asia. Parts of Japan, along the coast of the Sea of Japan, have been hammered by record snowfalls. In winter 2020-2021, some areas received over 7 feet of snow in just 3 days. Cold Siberian air, part of a displaced polar vortex, swept over the warm waters of the Sea of Japan, picking up massive moisture and dumping it as sea-effect snow. This intense precipitation trapped thousands. It cut off power. It triggered deadly avalanches. In February 2018, the polar vortex disruption, nicknamed the Beast from the East, sent a wave of Siberian cold across Europe. The United Kingdom saw its most significant snowfall in years. Red weather alerts, the highest level indicating a risk to life, were issued for snow for the first time. Behind the shocking statistics and the mind-bending science, there is a profound human cost to these extreme winter events. These are not just weather stories. They are stories of survival loss, community fragility. When a storm like the one in Buffalo or the deep freeze in Texas hits, the first and most immediate impact is on our infrastructure. The very systems we rely on for modern life. The power grid, transportation networks, communication lines are often the first to fail. A society built for predictable weather can be brought to its knees by an event that falls too far outside the historical norm. Think of the power grid. When temperatures plummet, demand for electricity for heating skyrockets. At the same time, the extreme cold and ice can physically damage the infrastructure itself. Power lines snap under the weight of ice, transformers fail, natural gas pipelines froze, cutting off fuel to the power plants that were needed most. This creates a cascade of failure. Without power, there's no heat. Homes that rely on electricity become dangerously cold, leading to hypothermia. The cosmos has taught us a profound lesson. Everything is connected. The carbon atom released from a tailpipe in Ohio is connected to the melting ice in the Arctic, is connected to the wobbly jet stream, is connected to the record snowfall in the mountains of Japan. We are not separate from our planet's climate, we are an integral part of it. The extreme winters we are now experiencing are not random acts of nature, they are the predictable, chaotic results of a system we have altered. This is sobering but not despair, it is a call to action. Our ingenuity that mapped the cosmos can be used here. The primary cause, excess heat trapped in our atmosphere. The solution? Stop adding to that heat. Transition away from fossil fuels, move toward solar, move toward wind, move toward geothermal. It's a monumental task, but achievable. The science is clear, the technology exists. This transition builds a more resilient world. We are stewards of this small, precious world.